Okay, so you should have just finished taking the notes. If you did not just finish taking these notes, you need to go back and watch the other video first because we are about to do the examples. So if you will flip over. On the back, first one I have is a rectangular prism. It does look like a cube. The reason I know it's not a cube is these three don't match. If they did match, then it would be a cube. But because they don't, it is a rectangular prism. For a rectangular prism, you find the area of the base. My base is a rectangle, which is 9 times 4, times the height of the figure, so times 9. When we multiply these, we get 324. My units is centimeters, and because it is volume, it is always cubed. Always, no matter what. So, volume of rectangular prisms or cubes are very easy. You just multiply your 3 dimensions. Next, I have a triangular prism. I know that because the base is a triangle. Remember, we talked about in the last video, even though it's not sitting on the base, it's sitting on a rectangle, the base is still a triangle. When you lay on your back doesn't become your feet. Your feet are still your feet, they're just down here now. So same thing, the base is still a triangle. So I need to find the area of the triangle first. Area of a triangle is 1/2 base times height. The base is 12. The height is 5. So this gives me the area of the triangle times the height of the whole figure. The height of your whole figure is the distance between your two bases. There is a base here and a base here. See the two triangles? So times the height of the whole figure. The height of the figure does not change because it is laying sideways. A lot of students want to tell me the height of this is 5 because that's the up and down one. Think about it. If your height is, I'm going to make something up, 5'5", from you're standing on your feet, if you lay down on your back, does your height change to 7 inches? No, your height is still 5'5". That has not changed. So just because this is not standing on the base does not mean the height has to be the one going up and down. The height is the distance between bases. If you need to write that down, please do. The height is the distance between the bases. The distance from this triangle to this triangle is 20. So when I multiply these, I get 600. This problem doesn't have units. It should. We're going to call it inches cubed. So these are your 2 prism examples. Next we have a cylinder. The formula for a cylinder is pi r squared h. So we're going to do pi. My radius is 6. My height is 8. Pi r squared h. My bad. Don't forget to square it. Now on your calculator, make sure you use the pi button. So if you're using Desmos, you can find the pi button on the little keyboard at the bottom. If you're using a school calculator, if you hit second, which is over here, the blue one, and this little up symbol, you see there's a blue pi symbol above it, that'll get you pi. So pi times 6 squared times 8 gets me 904 point, we're going to round 78. Now guys, I do want to let you know that on the classwork you're doing today, I actually give you these answers. And the reason I do that is because I want to make sure you are getting them correct and there's not a teacher here, or there may or may not be a math teacher here to check your work. So the part I actually want you to do is what I'm doing here. You're plugging the numbers in the formula. So you need to make sure that whatever you plug in actually equals the answer I gave you. If the answer I give you is not there, then that means you did something wrong and you should try again. So just kind of a heads up there, you have to show your work for these because that's literally the only part. I'm giving you the answers. I want you to do the work. Okay, back to this. Volume of a sphere is 4/3 pi times radius. My radius is 6 cubed. So we'll just put this in the calculator. 4/3, you can just do 4 divide 3, same thing, times pi times 6 cubed. Huh, funny, we got the exact same answer. That's really cool. So we got 904.78 meters cubed. So that is volume of a sphere. Down here, we have a square pyramid. Just a heads up, guys, I didn't go over this in the last video. If you just see pyramid, so you don't see triangular pyramid or square pyramid or hexagonal pyramid, whatever, it just says the word pyramid, it is automatically a square pyramid. I just need you to know that the word pyramid automatically implies square pyramid. So if it's not a square pyramid, they would have to say that. They would have to say triangular pyramid, pentagonal pyramid, hexagonal pyramid, whatever. So if it says just the word pyramid, it automatically implies a square one. And remember, we talked about rectangular pyramids do not exist. Okay, so finding the, sorry, my lights cut out again. Give me a second. Okay, so volume of a pyramid says we do area of the base. The base of this is a square, which means if one side is 10, the other side is also 10. Squares have the same number on each side. So area of the base is 10 times 10 times the height of the pyramid. We talked about how important it is the height must come from the middle. If it was slanted, we'd be doing Pythagorean theorem. So 10 times 10 times 12 divided by 3. Now, just to show you what the Pythagorean theorem part would look like, just in case they did this to you, if they gave you, I'm going to use a different color. Let's just pretend they gave you this number instead, and I'm just going to make a number up. Let's pretend they said that this was 20. If they told you this was 20 and didn't tell you what 12 was, this is just for pretend, but just so you know, if they told you this was 20, they didn't give you the height, I can do Pythagorean theorem because if this whole side is 10, I know that half of the side has to be 5. So now you can see there's a right triangle. I colored it blue. See that right triangle? Pythagorean theorem will solve right triangles for us. So let's just pretend, just for an example, because I don't have one of those, let's just pretend it gave you this instead. I would need to do Pythagorean theorem, which says a squared plus b squared equals c squared. Takes you back to middle school a little bit. The only thing that's important about this is c must be the hypotenuse. Your hypotenuse is your longest side. It's also always opposite of the right angle. So if I was to plug this in trying to find the height, we'll call a 5. So 5 squared plus b would be the missing height I don't have. So we'll call it h for height, equals 20 squared. And so 5 squared is 25. 20 squared is 400. 400, we have to subtract 25 from both sides. So h squared would be 375. And then you'd have to square root both sides. I don't know what the square root of 375 is. It is 19.4. So I know this is not part of this problem, but you're going to see problems like this, so I feel like it's important to go over this. If you had been given the slant height, you can use Pythagorean theorem to figure out what the height actually is, and then you would have to use the actual height. So I want to make sure you are aware of this because you are going to have problems like this, even though this wasn't one of them. Okay, that's a side note. Back to the actual problem. They did give us the base. They did give us the height. I can just plug this in the calculator. 10 times 10 times 12 divided by 3 is 400. This one's also missing units, so we'll call it inches cubed. So I know that the blue is not part of the problem, but you're going to have some that are. So if you run into it, this is how you do it. And we're about to do it over here too. So you get to see 2 of them. Okay, that is a square pyramid. Last example we're doing is a cone. The formula for a cone is pi r squared. We don't have r. We're going to have to find that. So r, whatever that's going to be, squared, times height. Be careful. There are two numbers here, and students are going to get mixed up on which one to use for the height. Use the one that comes from the middle. The height of this cone is 12. That's a slant height. So pi r squared times height, which is 12, divided by 3. So we just need to find r. And we are going to actually have to do Pythagorean theorem for this one. So I'm sure you guys can see that there is a right triangle here. If not, I'm going to color it so you have no choice but to see it. Right triangle. Again, we're doing a squared plus b squared equals c squared. C has to be the hypotenuse, which is your longest side. It's also always opposite of the right angle. So if I make RA, so r squared plus, we'll call 12b, 12 squared has to equal, hypotenuse is 13 squared. So let's simplify these. R squared plus 12 squared is 144. 13 squared is 169. If I subtract 144 from both sides, I get r squared equals 25. Oh, excuse me, guys. R squared is 25. And then I need to square root both sides. I find out that r is 5. Which means I can put this in my formula now. 5 squared. Excuse me. So pi r squared times the height divided by 3. So notice we didn't use 13 in the formula at all, but we did need it in order to figure out the radius. We could not have figured out the radius if we didn't know that slant height was 13. So this had to be done. So just so you know, guys, when you are working out these problems, if you run into a problem that requires Pythagorean theorem, you have to show the Pythagorean theorem work. You can't just tell me that r is 5 and you figured that out. I want to see how you figured that out. So does Ms. Tatter. So make sure you are writing all of these out. And then when we put this in the calculator, I get 314.16. This one's also missing units. We'll go centimeters cubed. So this video went over an example of every single type of problem you will see. And like I said, on your classwork for today, I gave you the answers. That way you are able to check to make sure you're doing it correctly. And then there will also be a Delta Math that doesn't give you the answers. You're going to have to put in the answers yourself. So that is all of the volume examples, and you guys can start on your classwork.